My name is Sridhar Rajagopalan. I am the Managing Director of Educational Initiatives. So Sudhir, myself and the third colleague, we kind of embarked on this journey. I would say we embarked on the journey about 17 years back when we started building the school in Ahmedabad called Eklavya School. EI is about 10 years old now, and it's been an exciting journey full of learning. The learning I have got this morning is about this very, very clear need, demand for teacher training, teacher assessment kind of things, which is kind of a little beyond what we're doing right now. So I'm going to keep that in mind and hopefully work with some of you to try and create something there that is really useful to you in that domain also. So yeah. With that, I'll start my presentation. The focus, as usual, for those of us who've kind of heard us right through these 10 the class, whether it is a child with special needs or a child studying in a government school, in a remote area. So that's the focus, and I'm going to talk about this. The way that we have planned this, my talk, I'm going to try and focus on 8 themes, and through these themes, take you through a lot of this, explain what we do, explain not so much the products, which we'll be focused on later on, but the kind of philosophy behind the products and the approach to them. And even while I speak, I would urge you to, if you have comments or feedback, to interrupt me, and so it can become a discussion and a two-way interaction. Yeah. So the first theme that has been at the kind of the focus of our work is what we call a focus on outcomes. What this means is that we are not simply looking at processes. In fact, one of the reasons why we have not had teacher training, for example, as a core offering over these years has been that we feel that the traditional approach to education has been focusing on doing things, trying to do different things, and kind of stopping there. And one of the things that we have tried to do is to say that the important thing is outcomes, is what is actually happening because of what we are doing. What is happening to teachers? What is happening to children? Are children really learning? I train my teachers. I make them go through a 6-day workshop. But what is the impact? Is there an impact? And what is that impact? And I think a time comes, which probably we are reaching today, when we are that message is kind of clear. People are looking at outcomes. And then there's absolutely no doubt that processes are equally important and need to be strengthened once we agree that, our focus is not simply to do the process, but our focus is to achieve the outcomes. This, by the way, becomes even more important when we are talking with governments, when we are talking about change. And one way of explaining this thing about outcomes is, to take this example. This is something that we have talked about, worried about, and used as a kind of an inspiration for ourselves, which is to say that why is it that in so many other areas, not just in technology, but in so many other, in the way we build our roads, in the way we are doing so many different things, we find that we are clearly able to say that yes, things have improved, things have changed. But are we really able to say that this is true for education? And again, I ask this question both for our private schools, sample of schools were represented here, as well as our government schools. And I would think that we are really not able to say that the quality of education we are offering today is much better than it was 20 years back. And is it possible to say that it is? Is it possible to reach a situation where we can all confidently say that it is? We believe it is possible. And we believe it is possible if in case we can work incessantly towards that goal, work together, and work with expertise in different areas towards achieving that goal. And that's a theme that I'm going to also be talking about as we go along. Okay. One important part of this, of course, for us is that our work is very, very significantly also with government schools. In fact, obviously, the number of children we touch through our work with government schools far exceeds the number that we do with private schools, simply because, for example, the entire city of Bombay We are now doing work with all municipal schools. Every single child in Gujarat who goes to a government school, we are doing work related to both assessment and learning improvement and so on. And this is happening with more states. I mean, we're working with Chhattisgarh on CCE. So there is a significant focus on working with the government school system. And I'm happy to say that, these two have kind of helped each other. We have learned and we have been able to take ideas across these two systems. And it's, of course, clearly two systems. There's a huge divide between them, but there are learnings that can be shared. And we hope clearly in all the work that we do with governments, we say that our benchmark is that the final learning outcomes the children should be as good, if not better, than what children are getting in situations where resources are absolutely not a constraint. So this is something that we're not going to talk too much about today, but I'll be referring to as we go along, and please feel free to discuss or ask questions if you have on that. When we say outcomes, we don't necessarily mean academic or cognitive outcomes alone. This too is, of course, most of our work in the last 10 years has been on cognitive learning, understanding, thinking, critical thinking, and so on. But we've started doing work on other kinds of outcomes. For example, what do we want to build in, what is the kind of child we expect to see as the product of the system? It's obviously not just the academic part of it. We're talking about holistic development. We're talking about attitudes, values. We're talking about sensitivity. We're talking about all their performance in the other intelligences, in physical skills and music and so on. And this is a study that has just been completed, something like assessments as the means for learning. The theme of assessment for learning is something we've spoken about for a number of years. Again, the basic principle that assessments is not an end in itself. For the first 7 years of our existence, till about 2007 or so, we had only one product, which was ASSET, which was a low-stakes assessment. But assessments is a means to something, and products like MindSpark, detailed assessment, the work we are doing with CCE or teacher support are basically trying to say that, yes, we will use assessment as a philosophy or an approach, but the goal clearly is we're not doing assessment for assessment's sake, but really to say that how can we as the group of teachers, the school, the system as a whole, help every child. So the purpose of the assessment is to help us help the child and not to kind of grade the child. So ASSET has been the main product in that space. It's being used now in a number of countries, and it's got a huge base because in a test like this, there are two dimensions, the diagnostic and the benchmarking. If I am running a class 6, if I'm running a school and I want to know how my class 6 class is doing, and this gives me a picture and tells me clearly, because it's a very large sample base, it gives me a very objective picture of where I'm strong and weak. Also, it's not someone's opinion. So if a teacher says, I don't agree that my children are not learning this well, it says, look, here is the data at the level of every child, every question. You can actually find out that your class performance is being pulled down because these children have not understood these concepts. If you can fix that, automatically the performance will go up. And the thing that a lot of schools do is actually measure that and to see what was the impact. Did that actually improve from year to year? So that's the basic principle behind ASSET. We do the same thing. These are numbers for ASSET, the private school test in English, but we are doing this in about 18 languages with state governments, with partners, where the principle is exactly the same. The tests are different, the languages are different, but on the same idea of using assessment, diagnostic assessment, as feedback for improvement. This is what the ASSET papers look like, covering 5 different subjects, so English, Maths, Science, but also Social Studies and Hindi, and across classes 3 to 10. Yeah. What ASSET is really based on is the principle that children must learn. They must not simply score marks. The goal of exams, why do we have schooling? Why do we have learning? You almost think that you're doing it because you want to earn marks, because you want to get into college, because you want a job. But there's nothing called learning in this picture. So and more the world is showing that if in case you learned, you're likely to do better than if in case you simply scored those marks and managed to get into that college. So that is the whole principle, and the basis of that is questions that may not look like the same question that you asked or that you were prepared for, but questions that check whether you have really understood or not. I'm sure that since most of you are familiar with asset, you're familiar with this question. It's a very interesting example because it looks like a very simple and straightforward question. This is asked in grades 4 to 7, and it looks like it's very simple. Everybody should get the answer. But only 11% of children in grade 4 say that the pencil is 5 centimeters long. About 75% say it is 6 centimeters long. And it's a very interesting example because you can actually try it with a nephew or a niece in that class. And it also typifies what we are doing. We are kind of emphasizing what's important in the exam, but not emphasizing a basic skill that's very, very important in real life. Of course, children do understand this. In class 9, they'll get this correct. So, somebody can say, how does it matter? They learn it by class 9. But the fact is that there are lots of skills to grade the child. So, asset has been the main product in that space. It's being used now in a number of countries. And it's got a huge base because in a test like this, there are two dimensions, the diagnostic and the benchmarking. If I am running a class 6, if I'm running a school and I want to know how my class 6 class is doing, and this gives me a picture and tells me clearly, because it's a very large sample base, it gives me a very objective picture of where I'm strong and weak. Also, it's not someone's opinion. So if a teacher says, I don't agree that my children are not learning this well, it says, look, here is the data at the level of every child, every question. You can actually find out that your class performance is being pulled down because these children have not understood these concepts. If you can fix that, automatically the performance will go up. And the thing that a lot of schools do is actually measure that and to see what was the impact. Did that actually improve from year to year? So that's the basic principle behind asset. We do the same thing. These are numbers for asset, the private school test in English. But we are doing this in about 18 languages with state governments, with partners, where the principle is exactly the same. The tests are different, the languages are different, but on the same idea of using assessment, diagnostic assessment, as feedback for improvement. This is what the asset papers look like, covering 5 different subjects, so English, Maths, Science, but also Social Studies and Hindi. And across classes 3 to 10. Yeah. What asset is really based on is the principle that children must learn. They must not simply score marks. The goal of exams, why do we have schooling? Why do we have learning? You almost think that you're doing it because you want to earn marks, because you want to get into college, because you want a job. But there's nothing called learning in this picture. So, and more the world is showing that if in case you learned, you're likely to do better than if in case you simply scored those marks and managed to get into that college, So that is the whole principle. And the basis of that is questions that may not look like the same question that you asked or that you were prepared for, but questions that check whether you have really understood or not. I'm sure that since most of you are familiar with asset, you're familiar with this question. It's a very interesting example because it looks like a very simple and straightforward question. This is asked in grades 4 to 7, and it looks like it's very simple. Everybody should get the answer. But only 11% of children in grade 4, say that the pencil is 5 centimeters long. About 75% say it is 6 centimeters long. And it's a very interesting example because, you can actually try it with a nephew or a niece in that class. And it also typifies what we are doing. We are kind of emphasizing what's important in the exam, but not emphasizing a basic skill that's very, very important in real life. Of course, children do understand this. In class 9, they'll get this correct. So, somebody can say, how does it matter? They learn it by class 9. But the fact is that there are lots of skills in about 18 languages, with state governments, with partners, where the principle is exactly the same. The tests are different, the languages are different, but on the same idea of using assessment, diagnostic assessment, as feedback for improvement. This is what the asset papers look like, covering 5 different subjects, so English, Maths, Science, but also Social Studies and Hindi, and across classes 3 to 10. Yeah. What asset is really based on is the principle that children must learn. They must not simply score marks. The goal of exams, why do we have schooling? Why do we have learning? You almost think that you're doing it because you want to earn marks, because you want to get into college, because you want a job. but there's nothing called learning in this picture. So and more the world is showing that if in case you learned, you're likely to do better than if in case you simply scored those marks and managed to get into that college. So that is the whole principle, and the basis of that is questions that may not look like the same question that you were asked or that you were prepared for, but questions that check whether you have really understood or not. I'm sure that since most of you are familiar with ASSET, you're familiar with this question. It's a very interesting example because it looks like a very simple and straightforward question. This is asked in grades 4 to 7, and it looks like it's very simple. Everybody should get the answer. But only 11% of children in grade 4, say that the pencil is 5 centimeters long. About 75% say it is 6 centimeters long. And it's a very interesting example because, you can actually try it with a nephew or a niece in that class. And it also typifies what we are doing. We are kind of emphasizing what's important in the exam, but not emphasizing a basic skill that's very, very important in real life. Of course, children do understand this. In class 9, they'll get this correct. So, somebody can say, how does it matter? They learn it by class 9. But the fact is that there are lots of skills we have learning. You almost think that you're doing it because you want to earn marks, because you want to get into college, because you want a job. But there's nothing called learning in this picture. So and more the world is showing that if in case you learned, you're likely to do better than if in case you simply scored those marks and managed to get into that college. So that is the whole principle, and the basis of that is questions that may not look like the same question that you were asked or that you were prepared for, but questions that check whether you have really understood or not. I'm sure that since most of you are familiar with ASSET, you're familiar with this question. It's a very interesting example because it looks like a very simple and straightforward question. This is asked in grades 4 to 7, and it looks like it's very simple. Everybody should get the answer. But only 11% of children in grade 4, say that the pencil is 5 centimeters long. About 75% say it is 6 centimeters long. And it's a very interesting example because, you can actually try it with a nephew or a niece in that class. And it also typifies what we are doing. We are kind of emphasizing what's important in the exam, but not emphasizing a basic skill that's very, very important in real life. Of course, children do understand this. In class 9, they'll get this correct. So, somebody can say, how does it matter? They learn it by class 9. But the fact is that there are lots of skills like the same question that you were asked or that you were prepared for, but questions that check whether you have really understood or not. I'm sure that since most of you are familiar with ASSET, you're familiar with this question. It's a very interesting example because it looks like a very simple and straightforward question. This is asked in grades 4 to 7, and it looks like it's very simple. Everybody should get the answer. But only 11% of children in grade 4, say that the pencil is 5 centimeters long. About 75% say it is 6 centimeters long. And it's a very interesting example because, you can actually try it with a nephew or a niece in that class. And it also typifies what we are doing. We are kind of emphasizing what's important in the exam, but not emphasizing a basic skill that's very, very important in real life. Of course, children do understand this. In class 9, they'll get this correct. So, somebody can say, how does it matter? They learn it by class 9. But the fact is that there are lots of skills. Looks like it's very simple. Everybody should get the answer. But only 11% of children in grade 4, say that the pencil is 5 centimeters long. About 75% say it is 6 centimeters long. And it's a very interesting example because, you can actually try it with a nephew or a niece in that class. And it also typifies what we are doing. We are kind of emphasizing what's important in the exam, but not emphasizing a basic skill that's very, very important in real life. Of course, children do understand this. In class 9 like this, and if in case I develop these skills, I develop the thinking ability, the problems our children are going to have to solve 15 years down the line, I mean, as you all know, we have absolutely no idea what they're going to be. And if they have the tools, which is skills, which is an ability to think, which is an ability to work with people together, they are likely to be able to do that effectively. So that is why it is important that they should understand and they should be able to learn. For the last 2 years now, we have been, the results are given in the form of a book, which is completely individualized to every child, because apart from the results of the child showing his marks question-wise, areas of weak and strong skills, one of the feedback from parents was that, can we have things the child can actually do that will help him strengthen the weak areas? So it now has a collection of questions that are based on the areas where the child was weak. So it's in the physical form. In the Ahmedabad seminar, people said, or some people said, why don't you just make it available online? It's very easy to make it available online, but the idea is that every parent has it in their hand. They can actually sit with the child. The child on his own can go through those questions. It's completely a low-stakes test. A key principle is it's not about the pressure and scoring, but it's about, can I improve? And we find that children also like this, the fact that the focus is not just on the mark, but the focus is on what can I do to get better. For the last year, we have introduced the same thing for the teacher. So the teacher also gets a book which is completely unique to that section or sections that he or she is teaching. And that means that these are the areas where your section has been strong, these are the areas where the section has been weak, and these are the actions. The teacher's book actually has clear suggestions, activities, remediation ideas that they can do based on the actual weaknesses that were discovered in his or her children. So that's the way that they get the results at the end of it. It's a book. For the school as a whole, for the principal, for the school groups, a picture that shows which are the areas where you are doing weaker than the average of other schools, and where are you doing stronger. And for schools that are doing very well, a similar kind of a graph is also presented with the top schools in the country based on the asset test. So this is one difference between benchmarking and comparison. We are not comparing school A, school B. In fact, you will find that none of these results have any names of schools. Even what we call the top 10 schools are not top 10 schools. It's actually the top 10 performing classes in every class and subject combination. So it may actually be 80 schools contributing to the top 10 school performance. But it's a very high benchmark, saying this is where you are against the top 10 schools, and this is where you are against the national average. And this provides a very clear picture that allows schools to know where they are in a non-threatening way, and yet to take specific action against it. It's also, the same thing is also available section-wise. So we find that the 7A and the 7B teachers find that, in 7A, the children are clearly not doing well in the topic of something in trigonometry or some topic in science, whereas in 7B they are. And we have seen that without our saying anything, the teachers actually talk among themselves. They said, can I know how you do this, or can I sit in your class when you're teaching this? And that's something which just happens when the teachers see these kind of results, because this is also available at a breakup at a section level. Various kinds of support given to teachers. One of them is the test generator, which we also have the more advanced form, which is a detailed assessment, which I'll talk about, and other things like this. I mean, for those who are kind of more inclined, and we've seen teachers getting into this, into understanding, okay, so why is it, or what is it the children are not learning? These kinds of analysis are possible from the data that is available. Without getting into the details of this, what this actually shows is that children think that they have some misconception about what is respiration, and they think that in this case, for example, plants using carbon dioxide is respiration. Fine. But what's interesting when you look at the data carefully is that this misconception does not reduce right from class 4 to class 9. That is what the yellow line on top shows. So it's like children were not very clear about it in grade 4, but on exactly the same question, the grade 9 children are not answering very differently. So that's because the format of the question, the thing it is asking them, may be a little different from what they are used to answering for exams. But it also clearly means that they are not understanding this particular idea. Somewhere the system may be giving them the impression that this understanding is not so important as long as you get the marks. And that's what we want to kind of gently challenge, saying, no, it is, if you understand this, there are lots of other things that fall into place and make sense. Many of you have already spoken about the asset question a day. There's another program called the Asset Week. We've done the Math Covery program. We did the teacher question making competition, which took a break for this year. But the purpose of all of these are free programs. I mean, we don't charge for anything in the asset space except for the actual test. They're also kind of, we just give the idea, and then we encourage schools, and we have found, a fantastic ecosystem where schools have, innovated, and then we share it, and they're also happy about it. And what basically happens is that the message to the child is, a question is not something that you fear and hate and do in an exam, which is about pressure. But a question is something exciting that teaches you something, and the process of thinking and answering it can be a very exciting one. There have been similar learnings about MindSpark that I will share later. but it's basically to bring back the excitement into learning, which is very much the need of the day, because in the coming 20 years, I think your marks are going to matter less than the question of, are you aware of your passion? Are you able to chase it? And are you able to become close to world class in the area of your interest? And if children leave school in grade 9 and 10 with a lot of concern about how they will do in the board exam, but no other kind of passion or interest, we may be doing the most disservice that we can. So this is one of those things which is not really a product. We do send these questions to schools every day, but it's just an idea, a purpose of changing the way that children look at learning. Similar kinds of projects, have happened. We are working with governments like the government of Bhutan, various states in India. The study that we did with the support of Google was covered in 18 or 19 states. And now with NCERT and MHRD, there are almost the final level of negotiations. We're doing something either at the grade 8 or 9 level, which is again looking at learning levels across the country. Yeah. So one of the things that these two focuses so far, about outcomes and assessments have kind of clearly brought out is that our success depends on how our children are finally doing. Are they really learning what they're supposed to be learning? And that there is an issue there. I mean, I'm not sure if you're aware, it's not yet very widely known, but among the government schools, there's an international test called the PISA test, PISA, and India participated, 2 states of India participated in the PISA test last year. 74 countries have participated in PISA, and in India, the 2 states of Himachal Pradesh and Tamil Nadu participated as a unit. Do you know the rank? Can you guess the rank of India among these 74 countries in PISA? It's something which is known. It's going to be officially released in about 2 or 3 weeks from now. This is class 10, and it is a representative sample of Himachal and Tamil Nadu. That means mostly government schools, a few private schools also, but mostly government schools. It's supposed to be a representative comparison. So you are able to, and these are known internationally. So it's internationally known that, say, Singapore or Korea comes right at the top. So any guesses on where India would be? No guesses? It's quite poor. That's a hint. Pardon? It's 73rd. It's 73rd, with the country of Kyrgyzstan scoring below India. So, this is, it's kind of, it's bad, but you didn't think that it was so bad. And when you actually have the data, you have the questions, you have the information available. But I think the positive of it is that we do see these kind of spurring governments into saying that, yes, by the way, our spending on education is not all that low these days. It's quite high. So, something we are doing which has to correct the thing. And one of them is, not focusing on whether children are learning, but simply treating education as going through the motions. The third theme that I want to talk about, which I think is, we've kind of talked about the approach and what we get from assessment. But if we have to solve these issues, one of the things that we think is necessary for everyone working in education is about building deep expertise in learning. And I'm just going to spend some time on that. So one of the things that you have to do if you want to do assessments properly is to understand what are children being expected to learn. So, and in a country like India where you have about 34 different boards, and you also want to benchmark against the best. You don't want to simply go by what's happening in the boards today. So one of the studies that we started off in 2003, it's something we do continuously, is called a learning standard study, in which we look at what are children expected to learn at every class and every subject level. We actually came up with a fairly detailed document. This study actually looked at 6 countries for every subject. So if you look at maths, then what is expected of children in Singapore? What is expected of children in some states of the US? What is expected in China? And in each subject, you looked at those countries that were known or you have results to show that they are very strong in that particular subject. So based on this, we came up with learning standards. That has been the basis of the asset test, and that keeps getting modified. It's not only international, it's also Obviously, the Indian states, it's about the National Curricular Framework, it's the NCERT syllabus, the other boards in fact, almost 20 different state boards, are looked at. And this kind of, you decide that, okay, what is it the children should be able to do in grade 6 in maths or grade 5 in science and so on. So this was the first thing that we started off. Every time we do an assessment, we actually, at the end of every assessment, we do some studies to understand why are the results what they are. Again, this is, so I showed you the question on the pencil, and I'm sure that many of you have seen the short 1-minute clip. Sound.
You counted that, and that's why you said that.
I'll just start it again.
1, 2, 3, 4, 5, 6, 7, 8.
So you counted that, and that's why you said that it's 8.
Yeah.
And not because this point is 8.
No.
This 4 will count as 1, and in 9 it will be 6. This is 1, 2, 3, 4, 5, 6.
Okay, I'm going to stop it here. So the idea is that the purpose of these studies, and there are a number of these, many of you would be aware of it. We are actually doing it continuously. The earlier ones are available on our website, would be available with many of you. But the idea is to continuously get into why our children, are they understanding, what is the gap? Because if you need to just know that there's a problem, maybe you don't need to do this. But if you want to fix the problem, or you want to know what do I have to do to make it better, whether it's through a teacher support program or through a program like MindSpark, this is one way of going deeper into how are children learning and why are these gaps happening. So this is something that we do regularly after every assessment, and it's a continuous process. In fact, in our development team, each member of the development team actually does one such interview once a month. That's the practice that we follow. Once we do these, how do we communicate this to teachers? How do we share this with schools? So we develop what are called teacher sheets, where this information, which is the question, the performance, but also the insights that you get through the interviews, for example, are communicated in the sheet, along with specific suggestions to teachers. Section 4 says, how do we handle this? Specific suggestions on how can this be captured. How can this be solved once you know that there is a gap over here? So this information is used both by teachers as well as our teams that work on remediation or doing workshops for teachers and so on. Okay. I just wanted to spend 2 minutes on things like this, because this is the way that we handle it internally, just to give you an idea. So what it says here is the learning genome, and I'll tell you why we call this a learning genome. This is just a term that we invented, and it conveys a message, and that is what we wanted to do. So, just as you have a human genome where the entire, the structure of the genes is mapped out, and this is what defines a human being, we think that we need to understand what is it that a child needs to learn, at least the common core, the basics that every child needs to learn. And we think this is, like the human genome, a very large, complicated, and detailed exercise. And as we start mapping that out, and as we get clarity on it, you kind of get into more and more depths and detail. And that is needed if in case you have to do assessment properly, maybe teacher assessment, teacher support, or remediation for children. Whether you want to create an educational software that's going to help children learn, or you want to actually teach in class and help children learn, you need to have this. And let me elaborate. So I'm just showing you a clip from what we would have for fractions, and we have this for a lot of topics. We've done this more in maths, second in science, third in language, but it's kind of going deeper in all these subjects. I'm also sharing this because if there are schools and teachers who are interested in participating, there are already schools that we work with closely on this. You're absolutely welcome to join in. So for example, the first column actually talks about misconceptions. It says what are the misconceptions that children have in fractions? Not understanding the concept, not understanding that this is about fractions, not understanding that the whole must be divided into equal parts, and so on. The second column actually has concrete examples. So if there is somebody new who's reading this, they can understand, okay, what is the test that you use to check if a child is suffering from this misconception or not? And as a teacher, you can use this in a class. If you ask this question, and you find that children answer this particular answer, it means they're suffering from this misconception. And we also have the data, which is not shown in this graph, of in a typical sample, what percentage would suffer from that misconception. So what is the misconception? How do you test it? What are the resources for it? And the last column is probably the most important. What can you do to fix this problem? And the complete thing actually is a combination of digital resources, activities, and teaching methods, because all three are needed. So for example, the second one is a digital resource, but the last one is actually a teaching strategy, saying that in a classroom, do this and do this with kids if you want to solve the issue of fraction representation, which is a misconception here. And every topic and subtopic actually has not hundreds, but I would say 10 to 12 misconceptions at every subtopic level. And it's not that every child has them. Children would have different ones of these. And if you can fix this, that is how the child learns the concepts. So this is just one example of how we believe that one has to go deep if in case we really have to have many children learning well. I think I'm going to just pause for a while somewhere here to just take comments and if there are clarifications. But we believe that it's because, now most of what I've shown you is not, we have not seen this happening in too many places in the world. It's not that there are lots of people working on it. That's why this becomes even more an urgent need, that for schools and people interested in learning, to get into this in detail. We've typically interacted with both companies, with governments, with universities, and we find that there are a few universities, a few of their departments, who are doing some work in this level of depth. But for example, one thing they tell us is that we do not get access to large-scale assessment data, so we are not able to go deeper. So there's not too much of work happening, and that's why partners, both internationally, nationally, state governments, are very happy to kind of recognize this and work closely, because they see that if you can go to this level of depth, that is how children can actually learn better. Two independent sources recently have listed EI as among the top 25 educational innovators in the world. One of them is a newspaper called the Huffington Post, which is putting a lot of attention into issues of social issues, which includes education. It's an American this thing. The second one is actually a foundation in Spain. In fact, we did not know of them, but we had a very exciting innovators meet where we actually got to interact with many interesting people, including Nitin Nauria, who's the Dean of Harvard Business School, also happens to be an Indian. But looking at innovative work happening in education, and in our case, this work on the science of learning is a thing that they thought was very interesting. So I think I'm going to just take a quick pause here in case there are questions. We've talked about these three themes, and I'm going to go into more things based on this. But if you have any comments or questions at this point, I can just take them. Or if you agree, disagree, or have points. Okay. Yeah.
I feel it's not because of the misconception. The curriculum demands are like that. Say, for example, when we are in the national curriculum of CBSE or State Board or ICSE, the mathematics, arithmetic, fractions when you take, it is more of numbers we see, and we don't see the pictures. We don't get into the real-life application problems. The more problems are abstract and numbers, whereas the quoted examples refers to more of application-based. Right. Real-life situations. Okay. This is where the international curriculum standards are maybe treated at par, or that's why the performance, if you ask the numbers test in them, they may not be doing well. Whereas that's what I feel. Good. Even so the measures, you gave an example of that length of a pencil. Yeah. Again, why the students need to, I feel it's more of confusing. Right. Why we need to confuse, put the pencil here, there, and all. They just need to measure from the beginning. That's what the students ask the question. And we have lots of tools. So I feel these questions are more confusing rather than concept clearing, I feel.
Right. Okay, so there are two important points that have come out here, and I want to quickly comment on both of them. The first is that misconceptions happen in children everywhere. It's not that it's happening only in India or, it's this thing. So a lot of this work, and that's why I mentioned that the work on misconception research or learning is of interest internationally. And unfortunately, or as of now, deep work is not, it's not that no work is happening. In fact, if you start off from zero, a lot of interesting work has happened on fractions, on measurement. There are lots of good researches and papers, but there are very few compared to what is needed in an area where, every child needs it and every teacher needs it. So that's the first clarification, that this is important. Children everywhere have misconceptions. I agree with you that many of the specific problems we face are because of the specific focus in our curriculum, and specific things are not focused. For example, a lack of focus on application and so on. But it's not to say that kids in China or America or something do not have certain misconceptions. But where teaching systems, where school systems are more geared to, teachers looking at what are the things that children are doing, where are the gaps, and then trying to clear them, they tend to be more successful in clearing the gaps. Where the focus is not so much on that, and you're saying, okay, I need to complete the curriculum and this is what I have to do. Even, for example, if you look at an activity like CCE, is CCE ensuring that children are actually learning better? What is the exact mechanism to ensure that? Those are the kind of things that we need to do to actually, help children learn. So that's I would say, the clarification between the fact that misconceptions are universal, but the specific misconceptions we find and the approach we take is what we need to do to make sure that they are actually getting cleared. And teachers need to understand this and be very clear about it. So if I'm going to step into a class to teach fractions, it really helps if I'm aware that, these are the kinds of challenges children normally face in fractions, and hence I can be aware from day one, from my first session, that, am I detecting and correcting it? So that's the point I would make. Yes, sir. Yeah, there's one comment here and then.
In your experience as an educator in India, why is it so difficult to persuade the boards to shift their kinds of questions to this kind of format?
Great. You've just talked about what I'm going to, my next theme, so I'll answer that under that theme. Yeah.
That would solve problems quite quickly.
I would also like to add on to what he said. Our main objective is just not imparting, just knowledge. Whatever knowledge we do impart in schools, the children have to apply them in the real life situations. Just knowing what is the length of a pencil will not actually work for the child, because the child has to apply that knowledge in his real life learnings. So that, how much has the child really taken it into himself? I think this helps us, Asset or MindSpark helps us to know how much the child has really understood the concept and how much has really gone into him.
Correct. I'll give some more examples of that as we are going through. But I think fantastic. I mean, this question just led me on to this theme. And we believe this. When we talk to governments, they say that we are interested in improving children learning up to class 5. And we say you have to improve your board exam. And they say, no, that's under secondary. And we really face this problem. And they say, your idea, once we explain it to them, they say it makes great sense, but unfortunately it's under secondary and we can't touch it. And fortunately, 1 or 2 states have broken that thing and said this. But you're absolutely right. If our board exams are the way they are, our kids will never learn. Right? Unfortunately, it's not only a board's problem, because if we talk to the boards, they say every time we try and make change, we get huge resistance from parents and schools. And we say, what are you saying? The parents in school want the change. But, we are like caught in a mess where you actually make a change and my parents will say, it's a great idea, but can you skip this year because my kid is going to take the 10th exam? Which is also fair, right? You can't make a sudden thing. But that's the problem. The problem is we have talked about this. I would say that the current attempts, what Mr. Sybil has said, what the CBSE has tried to do, the intention is the same. The intention is that we must make these changes, but I don't think it's getting reflected in that way. It's not actually causing the change. So I'll talk about 1 or 2 things that we think are doing that. And, for example, a very simple exercise. Let's look at a sample of exam questions from a state board. Let's look at a sample from CBSE, and let's look at a sample from some international test. And nothing great in this. A lot of insights come out. The MHRD's own, under the National Curriculum Framework, they had focus papers. The focus paper on assessment actually does some of this. It actually says that we are asking questions like, how much energy is equivalent to 1 AMU according to the equation E is equal to mc square, which is not so important for a child to know. They can pick it up and get it from sources, books, or the internet. It's much better if they had to be asked questions on understanding. But in spite of our saying all this, a lot of that continues. And this gets translated into the class 5 teacher, telling a student that you have to write, when you're asked to name 3 things made out of wood, you cannot write the wooden spatula because that's not written in the textbook. And you have to say this. And what does the parent say? Please do what the teacher says. You have an exam next week. So this kind of flows down from the board exam. The board exams don't test understanding. And if we can't change this, we are not going to be able to really help our children learn with understanding. There are studies, this is one thing that we had quoted, where we looked at both question types and the kind of skills being tested. And I think we all know the results, that our exams do tend to be very, very recall based or of a particular type. So what we are doing is, when we tell this to most states respond by saying that, all you're saying is theoretical, it makes sense for good private schools, but if you know the level of learning in our villages, this would never work. And we tell them that we know the level really well. In fact, we can share with you what is happening, but we think that only if we fix this is that going to change. Fortunately, one state agreed, which is Gujarat, and they actually said that, we do want to, even if it's going to create problems in the short term, if this is the right way to go, we'd like to go for it. And what we're doing with Gujarat, and incidentally, one more state has expressed interest in doing this. And we think that these front-running states will soon be followed by others gradually. But what we are doing here is exactly that, which is that the focus. So the first step is we are studying school leaving patterns across the world. So we are saying this is what the IB does, this is what Singapore does, and you'll actually have clear samples of each of these things. The second thing we are saying is that can you, building a kind of an ideal board paper, saying that here is a paper that seems to have a balance between understanding, knowing the facts that are needed, and the various skills in between. So that's the second piece. And the third and probably the most important piece is building a 5-year transition plan that says that if we had to switch to this over 5 years, we should not try that earlier because it would be a shock to the system. What do we need to do? And there are multiple stakeholders in this, apart from schools. I mean, there are parents, there are the coaching classes. You have a whole system out there, the students, and you have to take them along. So the purpose of this project is to look at these look at the best exams around the world, build a kind of an ideal paper, address questions like, how is technology going to change things? Can we visualize a situation where board exams will be taken at least partly or completely online? And people have started experiments on that. And questions like, on the ground, how will it change? How do the boards have to change? So the board has its own structure. It has people who do this. The board exams are an important source of revenue for the school, for the states, for the boards, which is one reason why some states don't want to change things. So that's the project. Like I said, a second state is also expressing interest. So we think that these are some important changes that will, it's like what we call changing the goalpost. If your goalpost requires recall-based learning, you can be sure that progressive people may think differently, but the majority will never change. The system will not change. So we think that this is an important thing that will play an important role in the times to come. The next theme really builds on my earlier point about building deep expertise into learning, and it talks about this idea called the science of learning. The science of learning is a new interdisciplinary field whose focus is how can anyone, learners or children, learn better. And the analogy I would say is that it is like management. I mean, in India there was nothing called the discipline of management before the 1960s, and internationally there was nothing called management before the 1900s or the first years of the century. What happened was, and if you read stories about the founding years of the IIMs and all that, they said that we wanted to have management experts who would join as faculty, but we realized there were no management experts. So we had to get people who were from the social sciences or maths and so on, and then they came together and they were actually trained in management, some by being sent to universities abroad, many by doing stuff like writing cases and so on. And we think that we need to do a similar thing with this idea called the science of learning, where people in education, we need to have a discipline which looks at this, which looks at learning and and give solutions to teachers in a more ready-made form than is available today. And I'll again come back to an example like fractions, or let me take this example on angles, right? Now, the question asks which of these is the largest angle, which of these has the greatest degree measure, you know? And 51% of children answered B, which is correct. It's an angle which has the largest degree measure. But that means 49% in class 6 actually answered this incorrectly, and 31% choose C. And analysis shows, if you talk to kids, you find that many children think that an angle whose arms, the lines are larger, is actually the larger angle. So there is this misconception. Now, why does this misconception arise? The misconception seems to arise because textbooks say, and this includes, by the way, the NCERT book, textbooks say that an angle is formed when two lines meet at a point, which is not incorrect, but it kind of reinforces the sense that that is an angle, and therefore if an angle is formed when two lines meet at a point, if my lines are longer, the angle is probably larger. We don't ask too many questions like this, and the child is able to get through because he learns about complementary angles, you subtract from 90, supplementary angles, angles of a triangle. But often then you find a lot of teachers will tell you children face difficulty using a protractor, But at the core of this is understanding that children have, for this concept to be learned, the basic concept of an angle has to be something about turn. It's not about simply using technology or animations. And I'm going to show you a sample from an animation that is from the internet.
What is an angle? An angle is made when two lines meet. Look for angles in the things around you.
So the point I want to make here is that if in case if I'm not clear about this, I can then build fancy material, but they will also reinforce the same misconception. Before a teacher walks into class to teach fractions or angles or evaporation or chemical change, the teacher must know that when this concept is introduced to a child or to children, there are certain potential misconceptions that can arise, and these could be potential solutions to it. This should not be research that every teacher has to do. This should be readily available to a teacher. The teacher can do more research based on their children after that. So in the case of angles, for example, we believe that the key idea is that of the turn, and not that, there should be one line which is horizontal. What if that line is not horizontal? If I turn the angle like this, does the angle measure change? If the lines become larger, does the angle measure change? These kinds of things are what, should be known. And it's not that in fact, this example was shared to us by people from the NGO Eklavya in Bhopal. And they said that, we take this chakradol, which is the giant wheel, and we show them that, this is how angles work. We actually take them and show them, right? So it's not about the use of technology. Technology helps. If in case I can visualize it, I can play around with it, this thing. But the concept is the important thing. This should be available to teachers, and this is the science of learning. The science of learning means that if I have to teach X, I should be able to, get into that and get the details relevant for it so that I can answer, so I can know this.
Excuse me.
Yes.
What I'm understanding from your misconcept questions is a kind of an aptitude test, which we get from so many books, these about the misconception. What we will welcome is if your product can support a classroom teaching, that will help improve the learning, rather than all these misconceptions, which in any case, children nowadays are so smart and they have an access to an internet. They sometimes know more than the teachers also. So if something can support the classroom teaching,
sure,
I think that will be a welcome.
Okay, good. I think I'll just talk about that in my next slide. So this is not about aptitude tests at all. And I'll... okay. What I'm going to do is I'll just go ahead 2 or 3 slides and then come back to these. And I'm going to show you something that's going to look complicated, but unfortunately it is complicated. This is about how children learn decimals, right? Now, I'll just explain this a bit, and then I'll... So there is, and I have these actually working, so I'll also show that to you afterwards, but I'm just showing it to you all on one screen first. Now, what we do to actually help children learn decimals, now what do we normally do is, we go through the exercises, we ask them, we teach a tens, we teach a hundreds, we make them do certain questions on it, and then we teach about addition and subtraction, and we move on. When you actually check and talk to these children and give them questions, you realize that they hold a lot of misconceptions. For example, a lot of children will tell you that 7.2 is less than 7.0024 because they look at 7.0024 as a large number with many digits and so on. In our earlier study, which we did 4 years back, we asked this question. We said, is 23.4 closer, which of these is 23.4 closer to? 23 or 234? 60% of children in class 6 answered 234. You can actually try this in the thing. So what happens is we teach them the procedures. We have an extremely huge procedural orientation in everything that we teach. So we teach them the procedures. If you asked him to add 23.4 and something else, he would do it correctly. But he answered the other question in the other way. So what happens in this is that the first part of this is actually what is called a decimal comparison test. This is, by the way, based on some research in the University of Melbourne, but there are other equivalent. We've modified it and changed it a bit, and there are other things that we've done here. But this nicely illustrates the kind of depth that one needs to go into. In the first part, the child is actually given 30 numbers, 30 pairs of numbers, which they have to simply, in each case, identify which number is the larger one. So they take about 5 minutes. They just have to click on the bigger number in each case. Based on that, they actually go through a game where they have to open the doors, and I'll show you this game, and identify which number is bigger. Is it the number at the top or the number at the bottom? Now, using these two inputs, you can actually tell what misconception the child has. And there are many different possible misconceptions. There are some children who simply look at the length of the number. There are some children who ignore the decimal point. There are some children who mix up with fractional thinking. So 1.4 and 1/4, there is some confusion between them. And you actually have, there's a name for each of these misconceptions. And based on which path they are on, they actually get 3 other activities which are focused. Actually, the activities are similar, but the questions, the numbers they get in the activities helps them to clear the misconception they have on decimals. And actually, after this, they again get that test, and you now check what has the improvement been. I'm just clarifying that this is therefore not an aptitude test. We are talking about understanding of decimals. We are talking about knowing the mistakes children make. And I'm saying that simply by playing games or accessing the net, or if I make something which I think is, if I try to sit down, if we sit down and say, let's make something fantastic for teaching decimals, I don't think we get to even 20-30% of this. Because this requires far deeper research. I can share with you papers on this, and there are many, many research papers on this area. This is what we mean by the science of learning. And I'll just quickly show you these things because I have them all here. Right? This is the decimal comparison test. So it says 6.62 and 6.961. So okay, suppose I know this and I don't know this and whatever. So this is what the child has to do after going through all the 30 and then completes it. Right? Now I just did something here. In this game, I have to open the doors to know which number is bigger. So, does he realize that if in case he opened this and they were different, he already has the answer. He doesn't need to open anymore. Okay, great, I can tell. Or does he think that he must see what is the case? And by the way, he loses money every time he opens a door. So, you have to open a minimum number of doors and then decide that, okay, this number is bigger. This was the next one that I showed you here. I'll just show it to you. Right? So based on this, the system actually classifies you as a particular category and then takes you through other games. In this game, it's made like a game, but it basically says, what is this 0.2? Is it 0.022 or so on? And depending on your answers, it will actually give you easier or more difficult questions relating to this misconception. I'm sure this you will appreciate. It's very simple to understand. It says that this is 0 and this is 1. There is a cow at 0.3. If you click it correctly, so I clicked it, okay, reasonably correctly, I got this one correct. So basically the child has to identify where does 0.9 come between 0 and 1. And as I do it, it starts giving me, instead of 0.9, it will say 0.946. And some children will say it's now more than 1, it's a much larger number, and so on. And the next one is, again, a very simple one. It says between 4 and 5, there's 4 here and 5 here, give me any decimal number that is between 4 and 5. And as I answer it, I am actually getting, now it says, okay, I said 4.5, it said between 4.5 and 5, give me a number. Now, if in case I get, so it's checking whether I'm able to I really understand where the decimals lie. Now, these are some of the games and some of the types of numbers, just a sample to give you an idea that each of these actually does something very specific related to understanding of decimals. And that is how the child, and you actually look at the data, that you can see that when children got into this, out of 450 kids of class 5 who got into this, 240 had some problems where they were this thing. At the end of it, the problems are cleared for 210 of them. These are the kind of samples that you get. If you did not do this, if I simply gave them all questions to say that, okay, practice decimal addition, these misconceptions don't go away. It kind of adds up. It doesn't matter so much. It's not a life-threatening problem. But if you could clear this, it also makes the child feel that, okay, now I understand this. This is what is going on. So this is what is, now we think that in 10 years' time or 15 years' time, what we are sharing will be common knowledge among teachers. And hopefully we'll all be going to the next level of depth and detail. So this is another example of what we mean by the science of learning. But what I'm trying to also tell you is that this is a very concrete, doable, on-the-ground numbers thing. It's not something vague saying that, yeah, we all need to work more in learning. It's something very concrete that needs to be done. So the science of learning is about understanding how children learn, having clear lists of student misconceptions. These misconceptions are very clear-cut. We are able to say that 65% of children have, for example, you take the pencil question, try it with any group of children. In a system like ours, you'll get a certain performance. Try it with children in the US, you get a slightly different performance because their system does these things differently. One interesting thing about that question is there's very similar performance in India between private schools and government schools, which is not common in other cases, but in that particular question it is there. The science of learning is a field that does that. It's an interdisciplinary field because it builds on psychology, it builds on subjects like maths and science and so on, but also builds on areas like cognitive science, computer science, artificial intelligence, and so on. We think that in the future, there will be people who are very passionate about this field who will be able to gain, take a degree, get a BA or a BSc in the science of learning. That's the kind of vision that we think is possible. And there's a strong focus in this whole area on both research and training. You cannot do all this unless you're interacting with kids and understanding what are the problems they face. Which is why all this work that we do is always in partnership with schools, and that's why I said that we ask every person in our development team to interact with a class or a group of teachers in detail at least once a month and record those things and so on. Okay. So I'm moving on, but please stop me if there are questions. The next key theme is teacher support. And I'm going to just talk about one or two ideas in teacher support. But in ASSET, for example, one of our guidelines is that we do, apart from the other things, we also try and do 2 physical visits, to schools subsequently. And we are trying to find out ways, because as the numbers grow larger, it's becoming more difficult. Maybe we need some innovative ideas where, the senior teachers of schools that have taken ASSET in the past can provide this support, as our representatives or something like that. But we are able to today provide it for say about 500 to 700 schools out of about 1500 schools that take asset. So, but this is a physical support. There are other forms of teacher support, and I'm going to just talk about one or two of them. I'm going to go quickly through some of these slides because I'm a little behind on time. But essentially, the role of the teacher is going to change. The teacher has to be a facilitator. The teacher has to understand these aspects of learning. For us, we have kind of, incidentally, we've never charged. I mean, teacher support for us is not a product, but it is a kind of an add-on service that goes with every single product. So if in case I do asset or detailed assessment or MindSpark, teacher support is a part of that. Misconception videos are one form of sharing these learnings with the teachers and saying that this is the kind of gaps that children are facing. Right? I just wanted to spend, in fact, I have a full presentation on this, but I'm going to just show you 2 or 3 slides to tell you one of the things that we are looking at in teacher support. Right? Yeah. Essentially, what we are saying is that on the one hand, there is the child. The one at the top basically shows the child who is working on a system, and the system knows what are the gaps the children are facing. The second one is actually a teacher support tool, which is used by teachers before the class. That means they use it to determine where they are, what their strengths and weaknesses are, and how they should teach particular themes in the class. And the third one is something that the teacher is able to use with the system in the class itself while teaching a particular concept. And all these 3 get interlinked in the sense that if it is known that children are weak in a particular area, those themes are emphasized when the teacher is preparing, and they are also emphasized in the actual classroom itself. And out of these, I just want to spend 2 or 3 slides on this. So this is something that we are developing, that we may have in the next 2 years or so. We have some modules available. This is actually happening with a school in Rajkot. Now what happens in this is the teacher actually starts off and takes these 4 themes where the teacher actually first of all takes a test herself. But this is not like a teacher assessment in the sense it's not everyone doing it together. It's much, much less threatening. You do it at your own time and pace, and you do it in the topic that you want. It's not a common test. It's a test in the particular theme that you have to teach. Based on that, you can actually get remediation in that particular thing. If there are areas based on the test it was found that you were weak in, it actually provides you support in that. The third piece is giving the teacher insights about student thinking. And the fourth piece is additional resources like videos, like lesson plans, and research papers. Okay. I'm just going to quickly show you this. So the teacher actually takes a self-test. Again, this is a test on a particular theme. After they complete the test, they are told that this is your understanding of these areas and some of the areas where you need remediation. Remediation is provided in those areas. I'm skipping that part of it. And then you are also given support on so there's a lot of it here. I'm just showing you 1 or 2 samples. What are the common types of mistakes that children make in this particular topic? And then examples of actual resources that you can get, which is lesson plans, videos, and so on. If you're interested in this, we can discuss. This is not a product that we have as of now. It is something that, for example, in one school, we have committed 1 or 2 modules to be provided by January, but it's something that we are working towards gradually. Okay, so with that, I'm just going to, did you have a point? Okay, sorry. So this was the other theme on teacher support. The kind of theme in the middle which I had skipped is, of course, the technology piece. And I've already shown you some samples. I'm not going to give you more examples right now of this. We'll also be seeing it in the products. But I want to emphasize that technology is not a fad. It should not be. I mean, I also think that it has been. Like today, people are saying that we want to do this because children must use computers. Children will use computers. They will use it even if you don't do any of this. We need to use technology for 2 reasons. One is, you saw the decimals example. I can show you such an example in every topic. No teacher in the world can track what are the specific learning styles or learning misconceptions or issues with 40 children in the class. I must provide that kind of an individualized support if I really want children to learn. There is no other way to do it than technology. And the second reason is that if we want these solutions to work at scale, if we are okay with if 100 good schools in our metros get it, maybe we don't need technology. But if we really want this to work for thousands and lakhs of the entire previous theme I showed you about the teacher support tool, which says that this is available. It could be on a tablet, it could be on a computer, and I could take my test in fractions. I could see what the children are learning, what the gaps are, and the remediation that I need. We have to use technology. So that is why technology is a key piece. As a company, you must be aware that in the first 6 or 7 years when we offered our products, we had no technology-based product at all. We didn't come in, with technology. For the first 7 years, at least what schools saw was a paper test and results on paper. But gradually we're realizing with MindSpark, with personalized learning, that if children have to learn, it has to be something which is, geared to the individual child, and this needs technology. So that is why technology is the theme there. The technology is the only thing that can achieve what we call personalized learning. And personalized learning is about many things, and I think all of us are just scratching at the surfaces of it today. If I look at what MindSpark does today, I would say it's the first 20 or 30% of personalized learning. What is that? It includes starting with the pace of learning. So I have the same material. Some children do it faster, some children do it slower. They are not restricted that everyone has to move at the same pace. This is common. This is something that we already offer in MindSpark. But the second is the style of learning. And I'm not, so there's a lot of research on styles. And what we are talking about here is that, some children learn a theme better when it is presented in a problem form, saying that, can you solve this problem and move on to the next one? Some children learn it better when they see something on it which explains the whole thing to them and then gets them to do some simple, even the type of problems they like to do could be different. And there are very clear things that are found here saying that if I have to teach, for example, you saw the decimals example, you can have it through those kinds of games, you can have it through questions, you can have it through application things, you can have it through activities, so moving out of technology. So that is also an example of the style of learning. And various other things mentioned here, the depth to which I want to go in a particular topic. We now have, I don't think we are showing you today, but for example, we have what we call an enrichment module. We showed this in Ahmedabad, but we're not doing it here, I think. We have an enrichment module on a topic like magic squares. Now, magic squares is not in the syllabus, but it's very exciting for children who, it develops a love for maths, and some of them really love it. So what happens is that's what I mean by order and depth. Some children may go into it. The other child may say, no, while you're doing magic squares, can I explore something about pyramids of Egypt, because I find that more exciting. They're both kind of stepping out, but going deeper in the area that they want. These kinds of things are possible. And in fact, I wouldn't say it's trivial. It's a huge amount of, it's got to be relevant, absorbing content, which is why it will take time, and teachers will also contribute to that process in a big way. But these are the kinds of things that are possible with personalized support, everything that's written on this slide. And this is going to be possible with technology, partly because the technology will do it, but also partly because, and this is very important, the technology will free up the teacher to do some of these things that technology can't do.